Welcome to another shockingly low production value video about anatomy. Today we're going to tackle neuroanatomy. It's going to be a very, very brief presentation. I'm a chest radiologist and I don't do very much neuroanatomy. Just to get things out of the way or get things started for first-year medical students, there are three basic divisions of the brain. The cerebrum, which is this big fella right here. There's the cerebellum, which is this little fella more posteriorly, and then the smallest part of the brain is the brainstem, which is this area right here. Basically, if it's not part of the cerebrum and it's not part of the cerebellum, then it's part of the brainstem. What I'm going to emphasize today is the voluntary control of motion. And what we're going to do is we're going to look at the corticospinal tract. We're going to look at its origin. First, its origin obviously is in the cortex of the cerebrum, and the way that you find that is first you find the central sulcus. This is the central sulcus right here. Basically the ridges here are gyri and the grooves are sulci. This right here is the central sulcus, and the way that you can identify it is you can find this prominent hand bump in the precentral gyrus. So this is the precentral gyrus. That is where the primary motor cortex is located, and behind the central sulcus, that's where the primary sensory cortex is located. Anyway, here's our primary motor cortex right here, and what it does is that the cell bodies produce a neural impulse, and that's going to travel down the axons. The axons that it travels down in the cerebrum are going to be located in the posterior limb of the internal capsule. We're not going to be able to see those, so we're going to go ahead and put the brain aside and pick up another model. This is a model of the brainstem. So remember, everything that is not cerebrum and cerebellum is going to be brainstem. This is a model of the brainstem. The brainstem basically starts right here. This is the midbrain, and these are the cerebral peduncles, also known as the crus cerebri. Basically, the corticospinal tract runs in the crus cerebri. So these guys are basically of white matter. Next thing that happens is that the crus cerebri and the corticospinal tracts go through the pons. This is the pons right here. And if you look at cross-sectional images, to me anyway, the crus cerebri sort of disappears in the pons, and it sort of reemerges as if by magic here in the medulla. So this is the top of the medulla right here. And the corticospinal tracts now run in something called the medullary pyramid. So this is one pyramid right here, and this is another pyramid right here. This other bump more laterally, that is the medullary olive. So the next thing that's going to happen that we have to pay attention to is the so-called decussation of the corticospinal tract. And that occurs right here. You can see this little area of roughening right here on this model. Basically what happens is that the left corticospinal tract crosses over to the right, and the right corticospinal tract crosses over to the left, and then the corticospinal tracts proceed down the lower medulla and into the spinal cord. In the spinal cord, the corticospinal tract, the axons of the corticospinal tract will eventually synapse with the lower motor neurons. And it's the lower motor neurons that actually innervate skeletal muscle of the trunk and of the extremities. There's another tract that takes care of the face, the corticobulbar tract, which we're not going to go over. That finishes our very brief discussion. Thank you for your attention.